And of course, there's some non-ideality in the metal, including the contact resistance. Even you go from metal to metal, there's still a contact resistance, and it becomes more and more dominating. Another is the so-called skin effect. At high frequency, only the outer region are really conducting because of the shielding, right? So at higher frequency and lower resistivity and also wider line, we actually have this problem. Then your resistance is larger because the effective area is larger. So what I'm showing here is the current transferring either in or out. This is the current direction, into or out of the computer screen. Right, so remember, you might think, earlier I told you that you might think about, let me reduce my wire width, right? So if you reduce your wire width, actually now the capacitance doesn't reduce much, but the resistance go up. But on the other hand, because this part is not being used at high frequency, so maybe it's okay, not as bad as what we expect, right? But these are something you need to pay attention to when you design your circuit, right? Another thing is inductance. Inductance also getting more important because we have larger I and also higher frequency, right? So we have lower R. So but the most important thing is it's still not really like RF, but you will get ringing, overshoot. So what is ringing? When you have a step, you go up, then it takes a long time to settle. And this can becomes a noise and accidentally turn on or turn off a gate. Overshoot is even worse. It's also like ringing, but too much. And this can actually forward bias a diode. In a transistor, right? And then you also get to all this signal reflection and noise coupling. So a quick way to estimate the inductance is to use this equation, capacitance times L equals to this one. Okay, so this is important, but I'm not going to include this in the exam for the inductance, right? You can also calculate how fast does the light travel in 1 picosecond, and to see all this transmission line effect. Okay. Any questions so far about the wire? So that's it for the wire I want to discuss. You find that we have long ideality in capacitance and resistance. And when we need to deal with that, right? Some of them we're going to deal with that in the future class. Some of them we will just ignore, but I hope that you can remember this problem. In particular, nowadays, they are the dominating factor. Any questions? If no, another topic I want to cover